Hi, this video is about Green's theorem. We will explain to you guys, so hope you understand. Green's theorem. Green's theorem relates a line integral around a simple closed curve C to a double integral over the plane region D bounded by C. So from a single integral to a double integral. Like this, integral C f dot ds. So f is a vector field that moves around the C. First, we can compute using line integral directly, but what happens if we have two terms x and y? So this is why we apply Green's theorem. We have two conditions. First, counterclockwise, the equation is like this. Same to the for clockwise. The difference is only between negative for negative orientation or clockwise. So from a single integral to the double integral respect to the dx and dy. This is what we call Green's theorem. So Green's theorem will make us easy to solve the equation. We can evaluate or compute a line integral, flux integral, and work done by using Green's theorem. So that's all from me, MAIZURAH binti Muhammad KHAIRUL ANUAR, B01910131. Thank you.
Hi, I will explain about the Green's theorem and prove it using the MATLAB software. So this is the general equation from the Green's theorem that states that if D is a plane region with a boundary curve of C directed counterclockwise and F is a function of P and Q is a vector field differentiable throughout D, then this is the equation. So we will begin by taking C to the ellipse. This is the ellipse equation, x squared over 4 plus y squared over 9 equal to 1. Okay, so we will take D as the region inside the ellipse and we'll compute F5. F5 is x equal to 4x and y equal to 5y. So next, okay, it is evident from the plot that the vector field F is in this case everywhere tangent to the circle in the counterclockwise direction, so that the line integral should be positive. Now to evaluate, we use that the fact that RT parameterized to the circle T ds, which is T ds equal to dr dt dt. So this is the equation of real dot, and we will integrate the real dot to get the answer of 2 pi. This is the coding for ellipse that we have computed by plotting and the ellipse and the vector field. We will use the modified polar coordinates for the ellipse. So this is the 4x and 5y from the previous equation, and this is the axis beginning from negative 2.5 until 2.5 and from negative 3.5 until 3.5. This is the x-axis and y-axis. This is the equation of the ellipse. So this is the MATLAB and the coding that I have used. So I will click run. So okay, as you can see here, the ellipse is 2 cos t, 3 sin t, and the answer is 54 pi. And from the figure, we can clearly see that the arrow is pointing outwards of the ellipse, which is why we expect a positive answer, that is 54 pi. And that is all from me, AIMI NADHIRA binti Muhammad NOORAN, B0119100136. Thank you very much.
Hi, this is me, SITI MAISARAH binti ROHANI, and I want to explain to you guys about this example of Green's theorem of our group. We did this example as a team, and then here I want to share to you guys. So the question state that if C is the closed curve connected to the R region and all of these are continuous on R, so that the equation can be written as this one. The integration of C, the closed part, the closed integration of P plus Q is equal to double integration of region del Q over del X minus del P over del Y. And then the question is, compute the double integral on right hand side of Green's theorem with these both equation, and then the region enclosed by the half ellipse, which is this equation, and then the line with this both equation. So how to solve this equation? So the next step is you can see here that we know that P is equal to minus y to the power of 2 over 2 and Q is equal to the x to the power of 2 over 2. And then we can draw the figure. Before we draw the figure, you should find the x value, which is the horizontal value. Use the intersection calculation, you will get x is equal to 2. So from this equation, my friend will show you more deeply on this graph in the MATLAB. So I just want to show you the calculation of this, and then from this figure, you know, by using the previous equation given, and from this figure you know that the C is equal to C1 plus C2, where C1 is half of the ellipse, which is this segment, and C2 is the horizontal line segment, which is this segment from 2,5 until 2,9. Bear in mind that Green's theorem only applicable to the closed boundaries, which is like this example, only applicable for closed boundaries, Green's theorem. So to solve this question, you should integrate both sides. This integration of closed loop is the value of integration of C1 plus integration of C2. So from C2, we know that x is equal to 2, y is equal to 4t plus 5, and t varies from 0 to 1, and then we differentiate x and y, will get this equation, and then you put it in the equation to integrate. So the integration just as simple as the normal integration, and then you will have this value and mark it as second equation, and then we proceed to integration of the C1, which is the half ellipse. From this C1, you can get that x is equal to 2 plus 2 cos theta, y is equal to 7 plus square root 2 multiplied by sin theta, and theta is varies from 0 to pi. And the same step applied here. You should differentiate x and y, you will get this equation, and then put it on the inside the equation to integrate, but the range is from 0 to pi, and then it looks like a complex integration, but it's actually the simple integration. First thing first, you should separate it in two parts, which is first part, and then this is the second part, and you solve it separately. So for the first part, when you integrate the first part, you will get 0. How you will get 0? Actually, the step is same as you integrate the second part, so I will explain the steps at the second part. So to differentiate the second part, first thing first, you bring out all the constant, and then you will have minus 1 over 2, and then the integration of 0 to pi 2 plus 2 cos theta to the power of 2 minus 2 sin theta d theta. And then from this, you should expand this equation, multiply it, and then you will get this equation. And then after you get this equation, you apply the sum rule. the sum rule, and then you will have this equation, all of this equation, and then you solve this equation by integrating it separately, and then you will have 16 over 3, and then put it back in the equation, and then you will have minus 32 over 3. After that, remember that C is equal to C1 plus C2, right? So you should plus it together, and then you will have actually this is the first part, and the second part you plus it together, 0 plus with the minus 32 over 3, you will get minus 32 over 3, which is C2 is equal to minus 32 over 3. And then for the last part, then you will apply the C is equal to C1 plus C2. So you plus it together, and then you will have minus 334 over 3, which is approximately equal to minus 111.33. So in other words, the solution of this green theorem is equal to minus 111.33. That's all from me. Thank you so much. Hope you understand.
Hi, my name is Muhammad Shahril. To conclude, based on the written calculation and sketch graph, we can prove the shaded region obtained here using simulation. The region y greater than 7 is bounded by the both lines and ellipse. That's proven similar to the written calculation. With that, thank you.